Hi, this week we're going to be talking about the unit circle, not so much the unit circle, but actually the sine, cosine, and tangent of special angles and how they relate to the unit circle. So a couple of weeks ago, you had the unit circle in degrees, and today I'm going to focus on degrees, even though it's exactly the same for radians, but I just, to make things easier, want to focus on degrees. And so we made this unit circle, and we see these different angles, and one of the reasons that the unit circle is so special is that we can actually draw these triangles using these special angles. And there's a big deal about that. If you recall from the first video about the unit circle, that the radius of the unit circle is 1. Why is that a big deal? Well, it's a big deal because I can take this angle and make a triangle out of it. You saw I did this with 45 and with 60, and we did that last week or the week before as well. But I can take that and I can redraw it here. This is 30 degrees, and I know that the hypotenuse is 1 because the radius is the hypotenuse. That's actually a really big deal. I know the radius is 1, which makes the hypotenuse of this triangle 1. And the reason that's a big deal is I can use it to find the other sides. I know that this side is a half, and this side is root 3 over 2. Well, why do I care about all that? I care about that because the sine of 30, which I know is opposite over hypotenuse. If you remember SOHCAHTOA, I'll write that over here just to remind you. Opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. I know that the opposite is a half, and the hypotenuse is 1. Now I'm actually going to go over it in a different color. I'm going to go over it in like dark blue so that we can see it. It's always 1. Well, any number divided by 1 is just itself. And so the sine of 30 is a half. It's just whatever this side is. If I want to find the cosine of 30, I know it's going to be the adjacent over the hypotenuse. Well, the adjacent is root 3 over 2. Because the hypotenuse is 1, it's just going to be root 3 over 2. It helps us actually find the sine and cosine very easily because the sine is just the side opposite and the cosine is just the side adjacent. And that means that this little half here and this little root 3 over 2 are just the sine and cosine. The other thing it helps us with is I can write that as a point. Because the hypotenuse is 1, I know that whatever point this is just the x-coordinate, which is this length, root 3 over 2, and this is the y-coordinate, 1/2. It's just whatever that length is, and it helps me find those points. And so having the special right triangles and using the unit circle with its hypotenuse of 1 helps me find the sine, cosine, and tangent of all of these special angles. Now, what I'm going to do is I'm also going to find the sine, cosine, and tangent of 45 degrees and also of 60 degrees. And then we're going to look at them and we're going to use some of the things we know about the unit circle to find the sine and cosine of 0 and 90. And then we're going to use what we know about the coordinate plane in general and these angles to find all of these other points and the sine and cosine of them. And so I'm going to find 45 degrees. So if I look at that triangle, that 45-degree triangle, and it looks like this. I know it's a 45, 45, 90. That's 45 degrees. Because I know that hypotenuse is 1, I don't even really have to think about it right now. I can find the side opposite and I can find the side adjacent. Now I want to remind you that in 45-degree triangles, 45, 45, 90, whatever this is, the hypotenuse is x root 2. And so if x root 2 equals 1, I can divide by root 2 on both sides, and I get x equals 1 over root 2. And then I think in class we discussed rationalizing. And so when I rationalize, I get root 2 over 2 like this. So that means that the side opposite is root 2 over 2. And the side adjacent is root 2 over 2 because they're the same. It's a 45, 45, 90. Each of those angles is the same. And then voila, I can find the sine. I know the sine of 45 is root 2 over 2, and the cosine of 45 is just root 2 over 2. They're both the same, and I use the sides of the triangle. Yay! And so I can actually just fill those in here, root 2 over 2 and root 2 over 2, like that. I'm going to now find the stuff for 60 degrees. So let's draw that triangle for 60. Oops, sorry about the shaking there. So with 60, the hypotenuse is still 1. I know the short side, that's opposite of 30. The short side is a half, and that long side is root 3 over 2. And so because it's on the unit circle, I know that sine of 60 is just going to be the opposite over hypotenuse, or really in this case, it's just the opposite. That's what's nice about the unit circle, is that the sine is just the opposite and the cosine is just the adjacent. And then the other thing that's nice about it is that we know that that also gives us the coordinates of the points, because this point is whatever this x is, which is a half, and whatever this y is, which is root 3 over 2. And that leads us to the next bit, which is that the points on the unit circle, x comma y, are just cosine of whatever the angle is and sine of whatever the angle is. So that point is just cosine sine, and that's it. Some people like to say sine cosine, but it's actually the opposite. X equals cosine and y equals sine. And so that's great, because if I know the sine of the angle, I know the y coordinate. If I know the cosine of the angle, I know the x coordinate. Or the other way around, if I know the y coordinate, I know the sine. If I know the x coordinate, I know the cosine. Why is that a big deal? Because that's going to help us with these angles, the quadrant angles, where I can't draw a triangle for 0 or 360. I can't draw a triangle. I can't draw a triangle for 90 or for 180. There's no triangle that I can draw, but I can find the x and y coordinates of those angles, of those points. So for example, with 0, I know that this radius is 1, and it's on the x-axis. So this is actually the point 1, 0. That's what that point is. Well, knowing that x is cosine and that y is sine, I know that the cosine of 0 is 1 and the sine of 0 is 0. And the same thing with 360, because 0 and 360 are the same. So knowing the x and y coordinates in this case actually helped me find the sine and cosine. With 90 degrees, I know that this is 1, because that's the radius of the circle. We know that it's 1. And so this is actually the point 0, 1. Well, why is it important to know the x and y, the point? Because that means that the cosine of 90 is 0 and that the sine of 90 is 1. They're different. These two switch. With 180, I'm going this way. Now, this is a little bit different, because if I look at the x, y at the plane, I know that the x's are negative over here. So this is really negative 1, 0. Looks like I'm off the graph when I'm writing that. I'm going to write it underneath. Negative 1, 0. And that tells me that the cosine of 180 is negative 1, and the sine of 180 is 0. So it's very similar to actually 0 degrees. And then with 270, it kind of works a little bit like 90, but it also works like 0 and 180 in the sense that when I have my point, I know this is 1, but it's down low, so it's the point 0, negative 1, which tells me exactly what the cosine of 270 is, which is 0, and the sine of 270, which is negative 1. And so taking what we know about special triangles and taking the unit circle, which is so special for so many reasons, especially this reason, we can actually find, excuse me, the sine and cosine of all these different angles. Now, some other things that we have to think about with the unit circle. For example, even in just a regular coordinate plane, I know that quadrant 1 is up here, quadrant 2 is here, quadrant 3 is here, and quadrant 4 is down here on the right. And I also know that in quadrant 1, both x and y are positive. And in quadrant 2, these x's are negative, but the y's are positive. In quadrant 3, everybody's negative, and in quadrant 4, the x's are positive, but the y's are negative. These are positive x's, but negative y's. Why do I care about that? Because I can use this information to find the points using these points here. So for example, if I draw a right triangle for 120, I notice it's exactly the same as for 60, which means that the points are going to be very, very similar, except for that x is going to be negative. If I look at 135, it's the same as 45. That triangle is the same triangle, except for because it's in the second quadrant, I know that the x's are going to be negative. And so I can use these same numbers, but now my x's are negative. And for 150, I notice it's the same triangle as 30. When you get into pre-calc, you're going to talk about reference angles, and these are called reference angles, but I think we're not going to do that in this class, or at least not this week. So I know I can use the same numbers, except for the x's are negative. You may be saying to yourself, Miss X, why do I care about that? Well, because if I asked you, for example, what's the sine of 120 degrees? Well, I know this point, and I know that sine is y, so I know that it's just root 3 over 2. I don't have to use a calculator. I don't have to look it up. At some point, you'll probably make flashcards. I'm probably going to give you some flashcards online. But you don't have to really make it up because you can read it right off of the unit circle. And I realize, looking at this, oh good, you can see it. Some of these might be a little bit hard to see. I'm trying to keep it on camera here. So let's say I wanted to know what's the cosine of 135. Well, I can look right here. Here's the cosine of 135. It's negative root 2 over 2. And so having the unit circle, knowing the x and y coordinates, and knowing whether they're positive or negative actually makes it so that we can find the sine, and cosine of all these different angles. We haven't found tangent yet, and that's okay because this week I kind of want to focus on sine and cosine a little bit. So if I look at 210 and I draw a triangle, I notice that it's the closest to this. It's this little triangle. It's the same as 30, but it's in the third quadrant. Well, that means that everything is negative. So if I wanted to know, for example, what's the cosine of 210 degrees, I just look over here and I see that it's negative a half. For 225, I notice that the triangle, it's that middle triangle, which is the same as 45. And so I'm going to have the same numbers, except because they're in the third quadrant, they're both going to be negative. And so let's say I wanted to know what's the sine of 225. Well, I can look at whatever the y coordinate is, and I can write it negative root 2 over 2. And I realize that I made a mistake because the cosine of 210 is right here. It's negative root 3 over 2. And so I'm going to write that. I don't know why I wrote the other thing instead. 240 is very similar. It's that third outer triangle that's the same as 60 or 120. And so I'm going to have similar numbers, except for that they're both going to be negative. The same works for 300. And so I look at 300 and I think, gosh, that's the same as 60 or the same as 120. And so I can fill in those same numbers, but now I know that x is positive and y is negative. For 315, I know I didn't draw this exactly lovely, but it's the middle triangle. It's the same as 45. I can fill in those numbers, root 2 over 2, but I know that y is negative. And for 330, it's the same as 30 degrees. I really should go to here, but I did not draw this to scale. And so I can fill in my points, but now my y's are negative. And so, for example, if I wanted to know what is the sine of 330, or if I wanted to know what is the cosine of 300, I can look and I can find those things. If I look at the sine of 330, it's this y, it's negative a half. If I look at cosine of 300, I know it's just x, it's positive a half. They're kind of similar. They're not exactly the same. And the thing is that positives and negatives in this case are really truly not the same. They're never the same ever. And some people just think, oh, it's something, but it's negative. Excuse me, they're not the same. So make sure if something's supposed to be negative that it's negative, and if something's supposed to be positive, it's positive. Your homework this week, besides this video, is going to be a couple websites. One where you're going to fill in all this information with the degrees and the radians and the points on a unit circle, kind of like you did last week. You just kind of had to like push the little button. You're going to have something very similar to that. And then one that kind of explains this again and has some multiple choice questions. If you're not sure or you don't understand or you want more help, make sure that you come to our class meetings. They are Tuesdays at 2:15 and Thursdays at 11:15. So Tuesdays at 2:15 and Thursdays at 11:15, or you can also always private message me or email me and I can try to answer questions like that. But come to the class meetings if you're not sure and we can discuss. And I hope you have a wonderful week.